Our next speaker, Ted Rowe. He's a Director of Research, National Aviation Reporting Center on Anomalous Phenomena, otherwise known as NARCAP. He co-founded NARCAP along with Dr. Richard Haynes, a NASA Ames senior research scientist at the time frame of 1999. NARCAP overall documents and analyzes UAP reports from pilots, explores trends in the data, and promotes research and analysis through publication and outreach. NARCAP is a nonprofit research group. And with that introduction, Ted, I'll turn it over to you. Thank you.
Thank you. Thank you, Ed. And a thank you to the organizers and, of course, to our host, the American Institute of Aeronautics and Astronautics. This is a rare opportunity and one I've hoped for a long time. My name is Ted Rowe. I'm going to talk to you a bit about civil aviation and aviation safety matters because that's been our primary thrust for the last 20 years. So we've listened to cases and incidents and with Ryan, he's brought up some safety factor issues. I'm going to expand on that a little bit more. Next slide, please. Thank you. During his 40-year career at NASA as a perceptual psychologist and human factors expert, Dr. Richard Haynes collected over 3,000 aviation-related reports of incidents and observations involving lights and objects the aircrews could not identify. In 1999, he prepared an analysis of 100 safety-related incidents involving American aircrews, and he titled it Aviation Safety in America, a Previously Neglected Factor. And inside of this, he identified several specific safety factors associated with UAP encounters. Close pacing is the first one. This is where, now keep in mind, we're talking about civilian aircraft, commercial aircrews. Okay, these are not fighter pilots. They're flying on a trajectory, they're zooming along, getting from point A to point B. So one of the more common reports we get are close pacing. When we have a UAP pull up near the aircraft and pace it for any period of time. Another is loss of separation to less than 1,000 feet. Collision headings and high rates of closure. So we have the object coming right at you and you may feel that you need to put in a control input. Near midair collisions, concurrent electrical system failures, and we're going to talk a little more about that in a minute. Intermittent radar detection, crew distraction, and incursions into Class B restricted airspace over airports. All of this creates safety hazards. All of these are safety hazards that have been reported to us. That's just 100 examples. We have many more. Next screen, please. In the process of preparing this study, Dr. Haynes repeatedly encountered underreporting bias. Pilots and air traffic controllers often do not report these incidents and observations out of fear for their reputations and their careers. And compounding the matter, the Federal Aviation Administration, the FAA, does not accept or analyze pilot or ATC reports of UFO. And per the FAA Aeronautics Instruction Manual, the AIM, Chapter 774, refers them to civilian organizations. So nobody wants to talk to a pilot that's seen a UFO in civil and commercial aviation. Reports and information regarding aviation safety-related UAP incidents and observations flow away from the aviation system and safety planners, leaving aircrews with no leadership guidance. And this is a problem that I'm hoping that this discussion today will help gain some leverage on so that we can start collecting data directly from the aviation system. Next screen, please. So during the summer of 1999, Dr. Haynes and I discussed his study and decided to develop a data collection program to gain more information. It was clear that the aviation community wasn't being served on this subject at the moment, and we felt that lives were in the balance. Due to the apparent underreporting bias, we decided to set up a confidential reporting system modeled after the FAA's aviation safety reporting system protocols. That way a pilot can contact us, we can validate that he is a pilot and he is who he says he was, and then we can de-identify his case before it goes public, minimizing repercussions on him and his career. We also defined and introduced the term or UAP to provide a more accurate and less stigmatized term. I know Robbie offered a definition in his presentation. Dr. Haynes has had one since 1980. And it's fairly clear. I didn't post it up here, but it's on our site. And then we conducted a search for historical information about aviation-related incidents and observations that might involve UAP, because we're waiting for pilots to talk to us, and they're not running at us in droves. In the process, we participated in some briefings. We briefed congressmen in 2003, participated or supported a congressional hearing in 2005. We briefed the FAA's aviation safety reporting system analysts in 2003 or 4, I think it was. We were invited to join a research agreement with the government of Chile's UAP research team, the Committee for the Study of Anomalous Aerial Phenomena, or CFAA. And we gained a cordial relationship with the French research program, CNES Japan. We've supported research teams. We've led research inquiries like Project Sphere, which involved multiple authors examining all different aspects of the UAP that present as spherical targets. Next screen, please. Our primary interest and focus have been on safety-related incidents. If it didn't include safety factors, we documented it as an observation, but we didn't include it in our safety data. We were very interested also in UAP appearances and characteristics, flight dynamics, and human factors around, including the underreporting bias, and understanding the cause of resistance to UAP research by the aviation and science community. We worked on identifying and developing relationships with international teams and researchers, while AV21 public, which is who we actually serve. If you can go to the next screen, please. We develop our data from several sources, the first being the reporting center. It's not that well known. We've been around 20 years, but we haven't been promoted widely in the aviation system, so we don't have an endless stream of observations, and we're certain that there are more cases out there than we are aware of. We receive up to a dozen cases per month. Most are historical reports, some are resolved. There are 1 or 2 cases per year that are actionable and may resolve as unidentified. In that case, actionable cases are reported within days of the occurrence so that we can generate Freedom of Information Act requests and retrieve audio and radar data. Interviews are conducted, and if the case remains unidentified, they're added to the database. Historical cases are documented, interviews conducted, and added to the database if they're not resolved as mundane. Additionally, one of our international technical specialists, Dominic Weinstein, prepared a catalog of 1,300 pilot reports ranging from 1916 till 2000. And that's been a very helpful source as well. If you could go to the next screen, please. And what we learned is that there are profiles of UAP and common characteristics. They share common characteristics. They share common flight characteristics. And then we were able to understand the incident profiles involving aircraft. So if you could, next screen, please. So the 4 UAP profiles commonly reported by pilots, the first 3 are objects. They're discs or spheres, they're cylinders. And then finally, there are balls of light, which are in a separate category, and I'll explain that in a minute. All of these objects can range in size from a few feet to larger than commercial aircraft. And they've been reported in every variation by pilots for the last 100 years. And they're the primary ones that we see when we look at our 1,300 case file. Next screen, please. So when we look at balls of light, they're very interesting, all right, because we don't know if they're masking an object or not. At least from our perspective, perhaps our military radars can tell us something else, but when we see a ball of light, we aren't certain what's going on there. We know that ball lightning has a duration of 5 to 7 seconds. These things have ridiculous durations. They come into view lit up and they leave lit up, and if they're there for an hour, then you have an hour of illumination. They have no visible surface other than the light. They're highly mobile. They have long durations. They can range in size from a few inches in diameter to larger than commercial aircraft. They're intermittently detected on radar. Sometimes we get them, sometimes they don't. A pilot will call in and ask for radar confirmation, and most of the time he won't get it. And this is a problem for safety factors because airborne collision avoidance systems that operate on radar won't detect them. And if they're not using TCAS, of course, transponder-based collision avoidance systems won't detect them either. Sometimes the reports involve multiple observations. There will be anywhere from 2 to 5. That's what we've seen in our files. I'm sure there are other cases with more. They appear in different colors and seem to coincide with a specific emission spectra, like atoms. A common color that we see in these phenomena is orange, and that suggests helium band. We have whitish greens, we have violet, we have green, we have red. So that they range in that across those colors, and they seem to suggest that they're plasmas. We're a strong inclination there. Dr. Haynes and Dominic Weinstein prepared a study called the NARCAP Technical Report 3, examining 57 cases of concurrent reports of electrical system failures during a UAP encounter, and all 57 cases involved balls of light. So there's some important clues in understanding balls of light and whether they represent something like an operating mode, you know, when one of the spherical objects decides to go into another mode or movement, that they implement a plasma shield around them. I don't know, but so we aren't really sure, you know, what they are, but we do know that they affect aircraft. Next slide, please. Now, all 4 of these UAP profiles share common characteristics, as Ryan mentioned and others have mentioned. There's no thrust port, no visible thrust, no blast. They're quiet. Ground observers describe them as silent. They do not use propulsive thrust and aerodynamic lift. They don't have wings or lifting surfaces. They often appear with a glow or a distortion around them. I've seen personally in our research and studies, I've seen a disc with an orange, very defined sphere around it, and the disc fit exactly in it, with nothing hanging out, if you want to call it that. And all 4 share the same flight characteristics. So if you go to the next screen, please. UAP have been reported by pilots to hover and to move very slowly, and as our other speakers have described, perform explosive accelerations faster than the eye can track. They can perform sudden decelerations to a dead stop or a hover, and I mean like snap, dead stop in midair. They can perform angular turns at speed. They don't have wings, or they don't deal with hydrodynamics per se, so they don't fly around a heading. They just change headings. So the presumption is that they experience little or no resistance to change in velocities or heading. They can move in any direction from any observed position, and they can move without orienting to a vertical axis. Somebody else mentioned that earlier, that they fly in ways that might seem counterintuitive. For example, you might see a cylinder flying end up, or end forward, or broadside. You might see it rotating, you might see it helicoptering. All of these are reported in these observations. Next screen, please. And our preliminary findings include the incident profiles. UAP observations and incidents have been reported over every region of the planet and can happen anywhere at any time, and that has nothing to do with weather or anything else. UAP observations and incidents have occurred from ground level to above cruise altitudes of commercial aircraft. A recent case that I worked involved a freight hauler over Mexico. It was a 767. They were cruising at 38,000 feet, doing around 500 miles an hour, when the UAP dropped into view from above and for 32 minutes. The pilot got out his cell phone and started shooting video of it, which was bokeh because the camera kept auto-focusing on the windscreen and then on the object, so you couldn't get a really good view of what they were looking at outside the window. But then he turned around and he aimed it at his radar, onboard radar system, and there was no target at all. And this is the thing that we're concerned about in safety factors. You can't detect these things unless you see it. You don't know it's there. The idea that perhaps it will get out of your way because somebody else cares about not hitting you is just a hope. We don't know. And even if it is somebody operating on the other end, you can have mistakes. Things can happen. So pilots are unsupported in this area. They're often undetectable by radar. Most reports begin with a visual observation by the crew. So you rarely have air traffic controller vectoring aircraft away from UAP targets. They don't detect it first. And the primary safety factor with UAP is for the commercial and civil aviation crew is that they're unexpected and unpredictable. We don't know when they're going to happen. And on top of it, they don't know what to do. And there's nobody to tell it to once they have one of these incidents. So these are like real issues as far as dealing with UAP and when you have souls on board. It's very interesting to look at the physics of these things and to chase them around with our F-18s and try to understand what they're about. But lives are in the balance here, and many more flights take place on any given day than military flights all over the world. So if you can go to the next screen, please. Next screen, Ed. Thank you. And one thing we've learned about these profiles is that they all share common flight characteristics. Well, that went backwards, Ed. Next screen. Thank you. No, back one. Thank you. Okay, so UAP and incidents and observations have a low frequency of occurrence, and that's a preliminary estimate based on a limited aircrew survey. We don't encourage pilots to talk about these things, so we really don't know what the real numbers are or how often they occur. We do know that incidents can be quite harrowing, particularly when they involve multiple objects, or depending on the phase of flight that the aircraft is in. If they're in a landing phase, takeoff phase, somewhere critical, unplanned control inputs could lead to catastrophe. And for those who are listening, who are researchers who are trying to understand how they might open a research effort here, aerial UAP observations and incidents are supported by ground observations. So a lot of what we see, what pilots are reporting is also being reported by observers on the ground. And you can look at the observer databases there and see very similar observations of UAP and very similar reports. There are also places where UAP occur repeatedly. Hessel in Norway is one of them. Professor Erling Strand at Oswald College has maintained an observation program at Hesselen for about 30 years now, collecting automated data from his blue box, he calls it. Learned in the process is that there are many other sites where these things occur, and I've actually spent some time with Mr. Strand in other locations where we've observed unidentified aerial phenomena in transit, in motion. And So finally, I would say that the most important thing that we can do to understand UAP from the aviation safety context is to develop a focused global reporting program that will provide a larger sample and offer a clear perspective on the scope and nature of UAP and their implications for aviation safety. In other words, we need more data, and it starts at home. We need to start backing up our pilots, encouraging them to report, and then exercise due diligence with the reports. And make sure that that data is secured somewhere public so that researchers can look more closely at them. And that's about all that I have to share right now as far as aviation safety and commercial aviation going at this point. If you have any questions, I'm happy to take them on.
All right, Ted, thank you so much. Quick apology for the momentary hiccup due to a Zoom message that interfered with the process. Anyways, let's move on. Question and answer for Ted, please.
Hi, Ted. This is Chris, head science writer over at the Debrief. Can you hear me okay?
Yes, Chris.
I had one clarification question on the characteristics of balls of light slide. You mentioned 57 documented cases reported concurrent failures of electrical systems.
Yes.
So obviously, since this is a safety issue, I want to make sure I'm reading that right. Is that of all the cases that were studied by NARCAP, the ones that had electrical interference were all balls of light, or all the balls of light cases were creating electrical interference? I'm trying to understand what that means.
Okay, so all of the cases where pilots reported concurrent failures of onboard electrical systems also reported during a UAP incident, described the UAP as a spherical ball of light.
Okay, so none of the other form factors you mentioned, the discs or spheres or any of these other things, have concurrent electrical failure. It's just these ball of light cases.
We have no data reflecting electrical interference from any of the other UAP, but of course this is very preliminary, and we need much more data in order to fully understand what these things are capable of.
Okay, great. That was my main question. Thank you.
Ted, I have a question. It's Peter Reale here.
Hi, Peter.
I briefly dropped out. I had a networking problem here, but I may have missed some part of it. But are there any incidents actually causing a crash of an airliner or anything like that, or that you know of?
The problem we have is validating it. We have stories, we have pilot reports. I have newspaper clippings of pilots that claim they hit flying saucers. The low survivability of air crews and the intermittent detectability of UAP on radar makes it difficult to tell if they played a role in a catastrophe. And so we're kind of stuck with that, but we have lost aircraft. The Mantell case is an example. He was, the Ground Observer Corps saw UAP. His Air National Guard unit was vectored to it. He chased it far above his oxygen level, blacked out, and fell to the ground. But it was a safety factor of his own making. It was pilot error. But we have lost pilots in UAP interactions, yes.
I just wondered if black boxes have ever reported anything, you know.
I don't know. That goes to the NTSB, and the NTSB I don't think takes on UAP cases. The only case I've ever seen that they took on that was where they said it was a UFO involved a Cessna 208 on a climb out from Mobile, Alabama. He got to about 3,000 feet, yelled, "I have to divert, I have to divert, I have to divert." And they found him balled up in the swamp with his propeller laying somewhere else. So they know he hit something. There were transfer marks on the aircraft that didn't belong to his plane, and they never resolved what it was he hit. There were speculations that he hit a drug runner that was flying in the shadow of a nearby wide body. But that was never validated or confirmed. There was speculation that it involved a UAV out of a nearby military base, but that was never confirmed either.
Thank you.
So as far as I know, NTSB doesn't touch these things at this point until there's a sea change around the topic of UAP investigations and accepting pilot reports. I doubt they will. Anyone else have any questions for me?
A question for you, sir. Santosh Kumar, member of the Pilots Association and Psycho Airspace Users Working Group. And
You're not coming through. You're not coming through. You're breaking up. I'm not getting even a.
Maybe it's the same person, Ted, but there was a note on my screen that showed that somebody had their hand raised to ask a question. And if it's not the same person, please go ahead.
Yes, I'm available. Anybody has anything to ask? Let's see, any new messages? No.
All right, Ted, why don't we wrap it up then? And
all right, thank you.
My sincere thanks. And we'll go on to our next speaker. Our next presenter is Philippe AIAA. He is currently with the European Space Agency as a project controller. It should be noted, though, that this presentation is undertaken as a personal work, not